I'm going to be taking you through the 4 graphs for both charging and discharging a capacitor. Now, centre there is the capacitor that we're going to be charging and discharging. I've drawn a circuit in such a way that I've got a switch at the top that can be positioned at A to charge the capacitor or B to discharge the capacitor. Now at the moment it's at B, and I'm stating that the capacitor is initially uncharged and therefore the voltmeter will read 0. So I flick the switch to A. This starts to charge the capacitor. Now, to take it in the most basic terms, when the capacitor is initially uncharged and no current's flowing, there is no charge particle stored on the capacitor whatsoever. So as soon as I flick the switch to A, it's very easy for electrons to start flowing around the circuit and starting to store on the capacitor. Now, the first electron finds it extremely easy. So if you can imagine, one electron has deposited itself on this plate, causing it to be slightly negative, which ejects an electron from this plate, which moves all the way around to complete the circuit. Then that's the basis. The second electron then comes around, and as it starts to approach the capacitor, there's already an electron there, which means that it has to do slightly more work, and it's more difficult to get that electron on. This process becomes even more difficult the more electrons are stored on the capacitor, until eventually the potential difference, the voltage across this capacitor, equals the supply voltage of 12, which means no more current can flow. Now, the graphs for these follow how easy or difficult it is for the current to flow. So if I go for the charging graphs for both current and voltage, the current at time 0 finds it extremely easy to flow, but as I suggested, as time goes on and the capacitor stores more and more charge, it becomes more and more difficult for the current to flow. So we have this exponential decay, where it decays rapidly to begin with and then slows with time. So it's got a steep gradient here, and the gradient decreases, which means the rate of current flow decreases with time, and eventually it will reach 0. Same regards for the charging voltage. Now, I said that initially the capacitor was uncharged and therefore the voltage starts from 0. Now, as the current finds it very easy to flow at the beginning, therefore the charging voltage will grow very quickly to begin with. And it will grow quickly, steep gradient to begin with. That looks as if it's gone beyond horizontal, which it shouldn't. This bit a bit better. And it will peak and settle at whatever the supply voltage is. So we go back. So now, the capacitor is fully charged. I flick the switch to B, which means the capacitor will release its charge through this lamp. Now, again, to appreciate and hopefully understand the discharging graphs for a capacitor, and I know this is a bit oversimplifying things, but so when it was charging, all the electrons flowed along here and deposited themselves on this. Now, when I release the switch from A and put it to B, then all these electrons will then flow down through this ammeter and up through the lamp to complete the circuit. So the ammeter flow when it was charging was up through the ammeter, and when discharging is down through the ammeter. So it's in the opposite direction. But again, when I flick the switch to B, the charge will flow easily to begin with and then decrease as there's less electrons to literally move around the circuit. Go to the graphs. So discharging current, you will see, has a negative aspect to it because it flows in the opposite direction, but similar type shapes. Starts off at a peak, exponential decay, eventually reaching zero. For the discharging voltage, now remember the capacitor was fully charged at A. I then flicked the switch from a fully charged capacitor, so it starts off with a peak, and again, in relation to the fact that the current decreases rapidly to begin with, then so too will the voltmeter reading. Again, starting from the 12 volts, which was the supply voltage, decreasing over time until it reaches zero and the capacitor is fully uncharged, or discharged, sorry.